to the assignment. So you will get 10% from that. And this is the presentation, the mini project presentation that I mentioned is you need to, right? So you need to record yourself, let's say teaching, okay, teaching about at least 5 different small topics on what I taught before. Okay, let's say you learn about shift. Okay, so you need to mention how to do shift. Okay, and then you also learn about the rotation. Okay, so you need to show on how to use rotation. Okay, for example. Okay, and also maybe you want to show how the memory allocation, or you are using the interrupt. Okay, how going to present that. Okay, so that will be your presentation. Okay, but at least 5 different instruction. Okay, 5 different instruction to be there. Okay, meaning that if you use shift, you need to mention about SHR, SHL. Okay, and then maybe you need to combine that with RCL, ROL, and up to 5 different instruction. Okay, but for those who did more, okay, I'm going to give bonus mark on your extra effort later. Okay, so that's it about the assembly programming quiz and also the project presentation. Okay, so
Doctor, may I ask?
yes.
How long should the video be?
It should be less than 10 minutes. Okay, usually between 5 to 10.
Okay, thank you.
But if you are willing to do more than 10 minutes, you are welcome to do so. Right? I just give you a rough guidance, but it should be at least 5 minutes. So 5 minutes, what you need to do is make sure that you can explain clearly, okay, the concept. Let's say SHR, okay, how you going to use SHR in the command, how do you put it, and then you need to give example, okay, what is the results after you put the SHR command. Okay, so that's the thing. Okay, so roughly it's about 5 to 10 minutes, but you can do more than 10 minutes. Okay, if uh, if your presentation is very attractive, okay, give you extra mark on that. Okay, so this is there is no this is actually individual. All right, there is no group presentation. Okay, so for this mini project, you need to do that by yourself. Okay, one more thing about test 2. All right, so actually I have marked half of the papers. I haven't finished another half of that. Right. What I can say is it is actually the same person got the same highest marks. All right. So I want to congratulate Arif and also Isma. Okay, both of them still got the highest mark for test 1 and test 2, but yeah, I still have half to go. For the rest, I'm not sure about your understanding. It seems like the answers are very different. I mean, from what is answered from Arif and also Isma is very different from the rest. Okay, I don't know how deep is understanding on, I mean, in terms of the subtopic, especially in terms of interrupt, okay, in terms of rotation, shift. It seems you still did errors there. Okay, So make sure you really put deep understanding on that, okay? Because the final will consist of uh, part of the topic from there, okay? But it might not be majorly the questions, all right? But it will be some part of the question will be asking you about that, because you know that in the in the assembly language, the instruction is related to each other. Okay, so some of the instruction you need to use it continuously. For example, the jump, okay, the rotate, okay, the shift, the rotation, interrupt, okay. So all of those you need to use that continuously. Because you already given, I mean, to look at the notes and to look at the book as well, and I already give you some example on that, right? So from your assignments, which is actually the answers is already there. So I don't think it's a problem for you to understand, okay, what is asked on that question. Okay, so I'm hoping that um, you did well in the final in order to get A in this course. But from what I can see, um, still majority of you maybe not probably getting an A for the subject. Okay, so might be around B or C, something like that. Okay, so I hope all of you struggle to get the A for this course. Okay, any other question? So today we're going to continue with a new chapter, which is chapter 6. All right. So it will be about the sign numbers. I'm going to share you the lecture notes. Give me 1 minute. Okay, there you go. So that's the chapter 6 lecture notes. Okay, so previously we have discussed about the keyboard and mouse programming. Okay, so now we look into, so previously we also learned about the signed and unsigned numbers, but now we are going to look into the string of that, the string of the signed numbers and the tables. Okay, so this is what you're going to learn, converting a number to 2's complement, all right? And then you will have a sign arithmetic instruction, addition, subtraction, I div, right? So I multiplication, I division. Okay, and you also have the code sign shift instruction, SAL and SAR. Okay, so and then the rest you also have compare, CMP, okay, CLD and STD. Okay, code instruction to control the direction flag. Okay, and then you have also more instructions there. Okay, for example, for table processing, you have X, LAT. Okay. Okay, so many applications require science data, and computer must be able to accommodate such number. Okay, for example, we have the most significant, okay, is set aside for plus or minus. As we did in the binary addition and binary subtraction, is if we get one, then the sign should be negative, right? If it is zero, it will be positive. Okay, and the rest of the bits are used for the magnitude. The sign is represented by zero, okay, and one is for negative. Okay, so this is what I mentioned. Okay, so this is what you learned before. Okay, so if D7 0, the operand is positive. If D7 1, it is negative. Okay, the range of positive number that can be represented by the format above, if from 0 to plus 1 to 7. Okay, so which you have up to 128 numbers. Okay, so if the positive number is larger than 127, a word size operand must be used. Okay, so that's up to 1 to 7. As you can see here, so we have 8 bit. Okay, we have 8 bit. So the bit here is used for the sign, right? So the rest are used for the numbers. Okay, so it is positive, but if it is all 111 and 1111, it will be minus 127. Okay, for the negative numbers, as we learned, the magnitude is represented in 2's complement. Always remember to do the subtraction. Okay, we need to take the 2's complement. Okay, so you are familiar with this concept. Okay, invert that bit. Okay, and then add 1 to it. So that's the 2 complement. Okay, so we have example here. We need to show how the computer would present minus 5. Okay, so we have 5 over there. Okay, so we have 5. And then we want to make it as negative. Okay, so this is positive, right? So this is positive. And then to make it negative, we need to invert. Okay, we need to take the 2 complements. Okay, we take the 2 complements. So this first we invert that, so it becomes 1111 and 1010, and then we add 1 to this. Okay, add 1. So it will become here. So 1, 1, 0, 1, 0, 1, and 1. Okay. Okay, so this is will be minus 5. Okay, and then we have example 6.2. Okay, so we have a number as minus 34. All right, minus 34. Okay, so we have 3 over there and then 4 over there. Okay, so this 3 to 1 is 3 and then there is 4. Okay, so we need to invert, right? We need to invert that as 2 complements in order to get negative number. Okay, so we invert that. So 1 1 0 0 1 0 1 1. Okay, and then you add 1 to that. Okay, and it becomes 0. Okay, you add 1 1 1 0 1. Okay, so 1 1 0 1 0 is 1. Okay, and then 1 0 0 1 1. So this is minus 34. Okay. All right, one more thing. All right, so this is equals in the hex equals CC. Okay, in the hex it is equals CC. Okay, and then it can represent minus 34. Okay, and in the hex over here for minus 5 it is equals to FB. Okay, this is F and this is B, so that's equals to minus 5. Okay, let's say we have a decimal number, okay, which is minus 128. Okay, so for decimal, okay, what we need to do is to, okay, so you know that this is to the power of 8. Okay, so this is power of 8. Okay, and then you have here it is 2 to the power of 16. All right, 2 to the power of 16. Okay, so sorry, so 2 to 1, 2 to, sorry, this is 2 to 8. Okay, 2 to 8. Okay, so this is 2 to 8. Okay, and then here is 2 to 2 to 3. Wait, give me a second. It's 2 to, okay, sorry, it's 2 to 7. Okay, it is 2 to 7. Let me erase that. Okay. Okay, here it is 2 to 7. Okay, so here it is 2 to 3. And then the rest, so you know, right? Okay, so you get 128 at 2 to 7. Okay, so you put 1 over there. Okay, but because you need it as negative, so you need to invert that. So it becomes 0, 1, 1, 1, and 1, 1, 1, 1. Okay, and then you need to add 1. Okay, you need to add 1. You need to add 1 back to that. Okay. Okay, become 0, 1, and 1, 0, 0, 0, and finally you get 1, 0. So it is the same number as above. Okay. So this is actually is not negative 0. Okay, as you mentioned over here. So because it is sign here is negative. Okay, and the rest is 0, so it's not negative 0. So it is actually minus 128. Okay, because 0 doesn't have negative. Okay, so the range of bite-sized negative numbers is from minus 1 to minus 128. Okay, so that's the size of negative numbers. Okay, so this is what you can see over there. So if you convert that, okay, so from decimal to binary to hex, so that is the equivalent number, right? So that is the equivalent number. Okay, so because this is always 8, okay, it's always 8 over there. Okay, because it's 1000. Okay, it's 1000. Okay, and then the representative over here, Okay, so we have minus 128. Okay, so this is 128 over there. So because it's minus, so you get the same number actually when you invert. But for 127, the original number is 0, 1, 1, and 1, 1, and 1, right? So this is the original 127. But when you do the inversion, okay, so you got 1, 0, 0, 0, and 0, 0, 0, 0, and plus 1. So you get 1, 0, 0, 0, 0, 1. Okay, so that's 127. Okay, so and the rest also you can do by yourself. Okay, so you see the difference between that. Okay, okay, so that's the sign number arithmetic operation of the negative numbers. Okay, a word is 16 bits in length, okay, in 86 computers. Okay, setting aside most significant bit, okay, D15, for the sign leaves a total of 15 bits. Okay, so 15 bits for the magnitude. Okay, the rest, okay, the rest is for the numbers except for D15, it is for the sign. Okay, similar to what you have here, as you can see that in the binary representative, if you have the negative number, all of the most significant bit will be 1. Okay, it will be 1. Okay, so for larger numbers, it must be treated as a multi-word operand and processed chunk by chunk. Okay, so mean that chunk by chunk is, okay, is for every 4 bit, 4 bit, and 4 bit. Okay, so that's chunk by chunk. So the same way as unsigned numbers. Okay, for example, we have these numbers, minus 3, 2, 7, and 6, 8. Okay, so that's the binary representative of that. Okay, and then for minus 2, so actually this can be supported up to minus 3 to 7, 6, 8, and up to 3 to 7, 6, 7. Okay, so that's the number that can be supported. So basically, the number is represented by, because you have 15 slots, right? 15 slots for the word. So it is actually 2 to power 15 at the maximum. Okay, so you get this one. So 2 to the power 15, you get 32768. Okay, and on the positive side, it is up to 32767. Okay, why is not 768? Because the 0 is also counted. Okay, so 0 up to here, we have 32768 numbers. Okay, so that's the difference between word and hex. Okay, so to convert a negative number to its word operand representation, the same 3 steps discussed in negative byte operands are used. Okay, so now you have the, let's say you have the hex number, or you have the binary number. How you want to invert that to get the real number? Okay, so you need to write the magnitude of number in 8-bit binary, no sign, invert each bit and add 1 to it. Okay, so when using sign numbers, a serious issue, the overflow problem. Okay, so we have the overflow problem, so it must be dealt with. Okay, so because the CPU only understands 0 and 1, so ignoring the human convention for positive and negative numbers, Okay, so the CPU indicates the problem with the overflow flag. Okay, if there is problem, so you will get OF, the overflow flag will become 1. Okay, so the results of an operation on signed numbers is too large for the register and overflow occurs. Okay, so we look over here. So we have example 6.4. Okay, so what we have, okay, in terms of dB, okay, so we have plus 96 and plus 70. Okay, so this needs to be converted to the binary representative of that. Okay, so 96 should be, okay, so this is 2 to the power of 3, 4, 5, 6. So 2 to 6. Okay, 2 to 6 and plus 2 to 5. So 2 to 5 is 32 and plus 64 you get 96. Okay, so that's 96 and then 70. So 70, so is 2 to the 2 to the 6 plus 2 to 2 and 2 to 1. Okay, so you get 70. Right, and then you add these two numbers. Okay, you add these two numbers. Okay, is that correct? Okay, so what you add, is it correct? Okay, so let's add that. Okay, so 0, 0, 0, okay, 0, 1, 1. Okay, so you get 1 and then 0, 1, okay, 1, 0 and 1. So you get 1 over there. Okay, so you get that. Okay, so what is this?
AC.
A6, all right? So you get A6. So in terms of hex, you will get A6. Okay, so but A6, okay, if you if you convert that, okay, you will get 90, okay, which is not the results, okay, which is not the results. So in order for you to get the correct result, okay, it need to show that the number is 166. Okay, over here, because the computer, right, because the CPU shows that the result is 90, okay, which is wrong. Okay, it is wrong. Then what you obtain here, right, what you obtain here is, okay, you get OF flag as 1. Okay, so you get OF flag as 1. Okay, so that's actually when you add those two numbers, it will give you error. Okay, so that's how, okay, so that's how the computer shows that the result is the wrong addition. Okay, okay, so it should be, because the sign is 1, right? So the sign is 1, it is should be negative over there, and then it's just counted this one and then all of those. Okay, so this is will be 990. Okay, okay, why this happen? Okay, why this happen? It is because the result, okay, was more than the AL could handle. Okay, so AL could not handle this, right? So because AL could only contain up to plus 127. Okay, so meaning that you need to use a larger register. Okay, so if the results of the addition is more than 127, you should, okay, you should change this. Okay, you cannot use AL, right? Okay, so what you should use is you should use 16-bit register. Okay, for example, AX. Okay, so then your result will be correct. Okay, in 8-bit signed numbers operation, OF is set to 1, okay, if there is carry, okay, from D6 to D7, but no carry out of D7, okay. So over here, CF is 0. There is a carry from D7 out, but no carry from D6 to D7, okay. So you look over here. So we have D6 to D7. Okay. So this is D6 and D7. Okay. So over here at the D7 it is 0. Okay, it is 0. But there is 1 there after D7. Okay. So over here, okay, over here OF is 1. Okay, over here OF is 1. Okay, and CF is 0. So meaning this is this case. Okay. Meaning that there is no carry out from D7 because it is just 1 here. So you don't need to add another 1. So there is no carry out from D7. But there is carry from D6 to D7. Okay. Meaning that from here, it needs to be carried out. Okay. It needs to be carried out from here to there. Okay. So that's for example over there. Okay, so let's have a look again. So okay, so let's say so this is from D0. Okay, so you have, and here is D7. Okay, and here is 0 is D6. Okay, we do again. So 0. Okay, so you bring D6 to D7, there is carry, right? Because you bring 1 over there. But from D7, there is no carry. Okay, there is no carry. Okay, but D6, from D7, there is carry. Okay, so this is the case. Okay, but if there is carry from D7, mean that you will sign that into CF. So that's why your CF will be 1 after that. But your OF will also be 1 if there is no carry. Okay, but when there is no carry from D6 to D7. Okay, so the overflow flag is set to 1 if there is a carry from D6 to D7, okay, or from D7 out, okay, but not both. Okay, if there is carry both from D6 to D7, and then from D out will still be carry, then OF will be 0. Okay, so in previous example, as I said, we have carry from D6 to D7, but there is no carry from D7 out. Okay, so OF is 1. Okay, so we look further in this example. Okay, so we have, okay, minus 128. Okay, so this is in terms of decimal. Okay, we want to put that into DL. Okay, DL can accept, right? Because it is up to minus 28. Okay, and then we add minus 2 to CH. Okay, CH to DL, right? And this result is wrong, right? Because it cannot be more than minus 28. So when you add minus 28, minus 128 add to minus 2, so it becomes, should be minus 130, right? But it cannot exceed minus 128. So that's why it will give error, because it will give you a positive number. Okay, because this is a sign positive, and the rest is considered as number, which is 126. Okay, that should not be the result. Okay, you should use a larger register to do this operation. Okay, so let's have a look at the results of the operation. Okay, so when you do the addition of these two numbers, so you can see that, okay, you add 0, 1, 1, 1, 1, and 1, 1, 1, and 0 over here, and there should be a carry out from D7. Okay, so when there is a carry out from D7, CF should be 1. Okay, and then OF also should be 1, because there is no carry from D6 to D7. Look over here, it is just 1, but there is no carry to D7. All right, so that's what we have. Okay, so you have carry out of D7, but there is no carry between D6 to D7. So you also have OF as 1. Okay, so this error is indicated by OF. Okay, so that's why OF is still 1. Okay, we have another example, 6.6. Okay, so from here, okay, we have minus 2 and minus 5. Okay, we add that to, okay, so this is correct, right? Because it's still within the range. Okay, you should get minus 7. Okay, so the sign, okay, show you negative. Okay, and then this number is, okay, this number is showing you the 7. Okay, F9. Okay, F9 showing you 7. Okay, so we did over here. Okay, so when we add, okay, we add these two numbers, become 1, and 1 plus 1 is 0, and 1 could become 0 and 1. So there is carry there, and 1 and 1. Okay, they want to that, and it's still 1, 1, 1. Okay, and still 1, and then there is carry. Okay, okay, so once you add that, okay, so what happened here? Okay, so OF, okay, OF becomes 0. Okay, so OF becomes 0, and then the results showing you that, okay, this should be, okay, this should be negative. Okay, it should be negative, so the flag SF becomes 1. Okay, it becomes 1, and then over here CF is 0. Okay, so it is inverse of that. Okay, even though there is out of D7, there is still a carry. Okay, but CF over here is 0. Okay, because over here the calculation is already correct, so meaning that it should not be brought to any more operation. Okay, and OF is also 0. But this one, okay, is negative due to the sign over there is 1. So your sign flag is 1 over there. So it is negative 7. Okay. Okay, so you know, right, to get how to get this binary representative, in order to get -2, okay, so what you should do first, do number 2, okay, as usual, okay, like that, okay, and then you invert this, okay, it becomes 1, 1, 1, and 1, 1, 0, 1, and then you add 1 to that, okay, you add 1, so you get 1, 1, 1, 1, and then 1, 1, it becomes 1, 1 is 1, 0. Okay, so you get this number. Okay, all right. So of course, this is 7. Okay, if you invert that, so from here it is 7 because it is 0, 1, 1, 1. Okay, and 1, 0, 0, 1. Okay. Some problem with my cursor. Okay. Okay. If how do you know if it is 7? So if you want to invert that, this is the rule. Okay, as I mentioned before. Okay, write them in the binary. Okay, invert each bit. Okay, and then add 1 to it. Okay, so over here you have 0, 1, 1, 1. Okay, don't take the sign. Okay, 1, 0, 1. So how do you know it is 7? So you invert that 1, 0, 0, 0, and then 0. Okay, 0, 1, 1, and 0. Okay, and then you add 1 to this, right? 1 to that. So it becomes 1, 1 and 1 and 1, 0, and 0, 0, 0, 1. Is it 7 over there? Let me redraw that again. Okay, so let me check on the other way around. So if it is 7, it should be 0, 0, 0, okay, and 0, okay, and then
0111. Is it right?
0, 1, 1, 0,
1.
1, okay. So this is 7, right? And then you add 1, so you get 0, 0. Sorry, 1 plus 1. It is not 7, right?
The left digit should be 0.
It should be 0 right here. Okay, it should be 0. So it becomes 1, 1, 1. Sorry, it becomes, if you add 1, 1, but over here it is 0. So here it is 4, 5, 6, 7. Okay, back to here. Okay, so this is okay 2 2 to 1, 2 to 2. Okay, so you have 4, okay, 5, 6, 7, right? So that's the number. Okay, this is 7. Okay, and then because you need to be negative, so you add 1 there, and then it becomes 0, and then 0. Sorry, you need to invert first. You need to first. Okay, becomes 1, 1, 1, 1, and then 1, 0, 0, 0. Okay, and then you add 1. Okay, so that's why you get this number. Okay, so you get that. Okay, so you need to invert first. This is 7, and then you invert that. Take, you need to do the 2 complement. Okay, add 1, and then you get this number. Okay, to invert back, okay, so to invert back, you need to invert back all of those. So it becomes 0, 0, 0, 0. Okay, and then it becomes 0, 1, 1, and 0. And then you add 1 to that. Okay, and then it become 1, 1, 1, and 0, and then 0, 0, 0, 0. Okay, so there is 7. Okay, so that's how you obtain, okay, the number, okay, from here. Okay, so you get number 7. Okay, is it clear? Any question? Okay, so let's go to example 6.7. Okay, after this, we're going to have a 10 to 15 minutes break. Okay, so let's have a look at this number. So we have plus 7. Okay, so this is 7, and this is 18. Okay, and then add those two numbers. So this one should be correct, right? Because it don't exceed plus 127. Okay, so this number will be 25. Okay, this number will be 25. Okay, the sign here is 0. Yes, it is plus. And then the number over there, okay, it is 25. Okay, it is 25. So because you need to invert this. Okay, so because you need to invert that. Okay, so you look back, okay, over here. Okay, so it is 25. Okay, so it is 25, which is equivalent to 19H. Okay, so 1, and then this is 9. Okay, from there, so how you get 25 back? Okay, so from here it is 0, okay, 0, 0. So you invert back, okay, 0, and then becomes 0, 1. It becomes 1 and 0. And then here it should be, it's 2 to the 8. Okay, so it is 1 over there. Okay, 2 to 8. Sorry, 2 to 7. So it should be 1 over here. Okay, it should be 1 over there, and then become 0, 2 to 6, 3, 4, 5, 6. Okay, 2 to the 6, and then you add 1 to that. Anyone can help me to invert this? How to get 25 from here? Okay, so for this one, right? So we already do the inversion, it's okay. But for this one, okay. Okay, so for here we don't do the inversion, right? So we just take directly the number, okay? So this is 2 to 4, 2 to 3, and then 2 to 1, okay? So 2 to 4, 16 plus 8, and then plus 1, okay? So it is 25. Okay, so only do the inversion when you have the negative number or negative integer. Okay, so over here there is no carry. Okay, there is no carry from D7 to D6 to D7, and then there is also no carry from D7 to out. Okay, so over here all of that are 0. Okay, so you get that? Okay, any question? Okay, so let's have a break for 10 to 15 minutes. Okay, then we will continue with the next example after this.
Okay, doctor. Okay, doctor.
So we're back. Okay, so let's have a look at another example. Okay, so this example will be in the 16-bit. Okay, so it will be example on 6.8 and 6.9. Okay, first of all, just to mention that whenever we have OF is 1 in the 16-bit number, right, then we need to ensure that there is a carry, okay, from D14 to D15, but there is no carry out from D15, okay, and a carry from D15 out, but not carry from D14 to D15. Okay, so similarly, like the 8-bit operation, so the OF flag is low, okay, is 0, if there is a carry from both D14 to D15 and out from D15. Okay, so let's have a look. So we have a 16-bit number here. Okay. So we have, okay, in terms of hex, okay, 6E to F. Okay. So it's 6E to F. So this is equivalent to 28,207. Okay, and then we, okay, so we know that the highest possible number, okay, the highest possible number for 16-bit is 2 to the power 15, okay, which is 32768. Okay, 32768. As mentioned before, 32768. So that's the maximum possible positive integer that we can, okay, we can keep. Okay, but here it is exceeded that. Okay, so of course OF flag will be 1. Okay, so we look at the addition of this number. Okay, so when we add these two, okay, so we have the sign flag of 1 here, which is negative. Okay, it is negative 3, okay, which is negative 325,253. Okay, negative 32253. So this is incorrect. Okay, that is incorrect. So what should be is this one. Okay, what should be is this one. And also the carry flag is 0. Okay, because okay here, because there's no carry out from okay the 15. Okay. So there is no carry out from here, so CF is 0. Okay, so in order to do this, okay, in order to do this operation, we need to reduce. We need to reduce the number, or we use multiple register, okay, to perform the calculation. Okay. So as we mentioned that you only have to limit of 16-bit register. So the other part of the calculation must be done within the memory. Okay, we have a number. Okay, so this one is 26. The addition is 26383. So which is less than this. Of course, it will be a correct answer. Okay, so we look at the addition. So 0, so is positive, and then the rest is 26383. Okay, so this is D214. Okay, D2 2 to 14, 2 to 14. Okay, and then add with the 2 to 13. Okay, and then you add all of the other part. Okay, 14, 13, 12, 11, 10. Okay, 2 to the 10, 2 to 9, 2 to 8, and then 2 to 3, 2 to 2, 2 to 1, 2 to 0, and then you will get this. Okay, and from here, okay, so OF0, CF0, and SF also is 0. Okay. All right, so
Doctor?
that's it for the 16-bit number. Okay, Timothy, you have any question?
Why is 32768 the highest number?
Okay, so because it is up to, okay, so you have 16-bit, right? 16-bit, okay? The 2 to 16 is for the sign, okay? It is either 0 or 1, okay? So you have only up to 2 to 15, okay? From,
So you can't use all 16 bits.
yes, it is all 16 bits, but
the last one is for the sign.
yes, for the sign.
Okay.
For the last one is for the sign. So the most possible number is up to 2 to 15, okay?
Up to 15 ones in binary.
Yes, 1 in the binary. 2 to 15, so you get the result as 3278, 768. So this is 2 to 15. Okay, it's clear? All right. Okay, so in order All right, so in order to avoid the error, okay, so we don't want the OF equals to 1. So what we need to do is, so we copy, okay, we copy the sign bit, okay, into another register, okay. So it can be done as well. So meaning that the sign bit, we put that into another register, and then we can use the upper bit of that register, okay, to assign a higher number, right? So that can be used as well. Or if you want to do more, we can use multiple register, okay? So let's say we use AX and also BX to combine for those two numbers, all right? So let's say we have word and multi-word, so word and word, so we have 16 and 16, so we can extend that. Okay, so in order to perform the sign extension, meaning that we want to use the sign to another register, so we need to use two directives, which is CBW and also CWD. Okay, where CBW is we convert byte, the sign byte to sign word, and then we convert sign word to double word. Convert word to double word. Okay, so that's the two directives that can be used. Okay, so how it works, okay, CBW will copy D7, the sign flag, to all bits of AH. Okay, for example, we have AX, right? We have AX, so we have a lower part and higher part. So higher part, which is 8-bit, and then higher part is also 8-bit. So we copy this sign bit to AH. Okay, so we put that over there. So we put that over here as the sign bit. Okay, so let's see how to do that in the instruction, in the code. Okay, so we have AL plus 96. Okay, so AL is 0 over there, and over here we have 1 1, okay, 0 0. So this is equals to 96. Okay, this is 2 2 4 5 6. Okay, 2 2 6 and 2 2 5. 2 to 6 is 64 plus 2 to 5. Okay, so you get 96. Okay, but you bring here, when you type CBW, so this 0 is bring to the AH. Okay, is bring to the AH. Okay, and then, okay, for the negative, okay, okay, it will be negative. So here is negative, and then others is 2. Okay, so to get 2, as I mentioned, so we need to invert first and then add 1. Okay, so invert 0 0 0 0 and then 0 0 0 1, and then you add 1. So of course it will be 2. Okay, okay, so you type CBW, and then this sign is brought to AH. Okay, so how it happens for the AH, it will be all of the register will be 1 1 1 1. Okay, so that mentioned that the sign has been transferred to the AH. Okay, so while, okay, so that one is for the byte to word, okay, CBW. Okay, now word to double word. Okay, so it should be between two 16-bit register. Okay, so for example, AX to DX. Okay, so from here, so you have AX number, let's say is plus 260. Okay, then DX becomes 0. Okay, and then for this one, so it's still similar because it is positive. Okay, so AX is this one, or in terms of that is 0104. Okay, and then in terms of negative, if you have this negative sign, so DX all become FFF, or becomes 111, and 111. So it is similar like that. All right. So that's so the dx. Okay. But for the ax, okay, for the ax, it will be 8002 in terms of the hex number. Okay, in terms of hex number. Okay, so to get this 3276, so you invert all of those, right? You invert all of those and then plus 1, then you will get 32766. Okay, so that's example of CBW and also CWD. Okay, so we have another example on how to handle the overflow problem. Okay, so to handle this, okay, for example, we have data 1, okay, plus data 2, okay, 96 plus 70. You know that the maximum possible number is 127, right? So 127 is the maximum possible addition that you can, maximum number that you can store in the 8-bit in the 8-bit register. Okay, so what you did is, okay, first you add, okay, you add, so BL is 170 and AL is 96. Okay, so you add them. Okay, so you add them, you will use jump instruction. Okay, jump and O. Okay, jump and O. J and O, which is jump no overflow. Okay, so if there is no overflow, meaning that the result is correct, okay, then it will move to the next. Okay, sorry, it will jump to the over. Okay, it will jump to over if it is correct. So mean that you just save it. But if it is wrong, okay, so if it is wrong, mean that it will instruct the next instruction. It won't jump. It won't jump. It will. So if jump is wrong, so this is your test 2 question. Okay, if jump is wrong, okay, meaning that jump is not instructed, so it will follow the next instruction. Okay, so it will go to here to actually to to fix this result. Okay, to fix that, as I mentioned, so you need to move that sign to another register. Okay, so move, okay, back the data 2 to AL. Okay, and then one from AL. So your AL now we have 70. Okay, and CBW, okay, meaning that this sign, okay, will be moved to CB, okay, CBW, okay, save it in the BX, okay, save that in the BX, okay, meaning that CBW, it will go to the AH, okay, it will go to AH, okay, when we move this, it will go to AH, and then you know that AH now becomes 000, and then that is saved to the BX. Okay. Okay, now move back the operand 1 to AL, and then CBW as well. Okay, CBW, and then that result, okay, that result will be extended. Okay, that the sign will be extended. Okay, so what you have then, AL now can be added. Okay, so now you add to those BX already one number. Okay, and now you have another AX. So now the sign will be at AH and BH. Okay, so basically you will have that. Okay, and then those you will have as okay, 7, and then sorry, it should be 70. So 70, it should be okay, like this. Okay, so you have AX like that. Okay, all of that is 0, and then 70 is 2 to the 5, 2 to 6. Okay, 2 to 6 plus 6. Okay, so 2 to 6, 3, 4, 5, 6. Okay, 2 to 6, and then we have another 6. So you have another 6, 0, 1, 1, 0. Okay, so that's your BX. Okay, so your BX becomes like that. And then your AX will be 96. All right. So it will be 0, 0, 0, 0, 0, 0, 0. Okay, and then 96. So mean that you have that as, so that's 2 to 6. Okay, and then 0, 1. So 2 to 6, 2 to 6 is 64. So you minus that with 96. How much left? So you still have 32. Okay, so you still have 32 is 2 to 4. So 2 to 5. Okay, so 2 to 5. So 0, 1, 1, 0, and then 0, 0, 0, 0. Okay, now your sign is here. Okay, so your sign is there. So now you can add those two numbers. Okay, so it will give you the correct result. Okay, so forget this. So this is BH. Okay, so you add those two. So 0, 1, 1, 0, and then 0, 1, and 0, 1. Okay, so the sign is there. Okay, so you get the correct number. Okay, so you get it correct, right? Okay, so because this is 2 to 7. Okay, 2 to 7, and then plus 2 to 5. Okay, 160, and then you add with here 6. Okay, so 166. Is it the result 166? Yes, it is 166. Okay, so that's the correct result. Okay, so that's how you fix the overflow error. Okay. Okay, so this is just the explanation. So it will become like this. Okay, so you should extend all of those. Okay, sign extend before you do the perform the addition. Okay, similar to word size operand. Okay, I think I'll stop here for today. All right, so we will discuss IDIF on next Thursday. Okay, so let's turn on your camera. Do you have any questions so far?
Okay, Doctor.
No question. All right. So turn on your camera for me to take your attendance for today. I'm going to count from 10. All right. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Cheers, everyone. Okay, thank you. All right. Have a nice day. Okay. Do you have any further question?
Doktor, yang video tu macam mana, Doktor?
Ya, macam mana?
About the assignment, the 10% assignment for the video, I quite cannot get it.
Okay. Macam okay, saya bagi contoh tadi macam saya bagi instruction, okay. CBW, right? So one instruction. So CW another one instruction. So you need to explain that. So you need to have at least 5 instructions. Let's say you have another, let's say instruction IDIF. Okay, so how to perform that IDIF, and then I mode. So at least 5, and then you need to record it and then upload to the YouTube.
So
Okay.
the video is just about us explaining the instruction je lah.
Yes. So you act like me. So you teach the how to use the instruction, but you must make sure you give example. Okay. For if I can understand, okay, what you explain, then you should get a good marks. All right. So make sure that you self understand first before you explain. Okay. So that's the assignment.
It's not, kita bukan create sendiri kan, if kita buat example yang ada dalam buku pun is dah okay.
Boleh, tapi yelah, you kena prepare the slide lah, right? Tapi you still need to prepare the slide.
Okay.
Okay, so if you can make it as interactive as possible, then that should be good. Also, kalau you nak guna whiteboard ke whatsoever, you can use it. Okay? Whatever teaching aid that you want to use, you can use it. Okay? So there is no restriction in that. You want to use video, or you want to use slides, you want to use the whiteboard, or whatever, the OneNote or whatsoever, you can use. Okay. All right. So thank you for today. So I see you again on Thursday. Okay. Assalamualaikum.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Welcome.